Okay, we are going to practice simplifying radicals. So, let me just make sure that this is big enough to see. Perfect. All right, so we're going to do 32 m to the third. And so I'm going to be using factor squares to look at it. So when you are simplifying radicals, you want to make sure that you are looking for perfect squares. Our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, right? So we want to find the biggest perfect square. So if I'm looking at 32, I know that 32 has the following factors. It has 1 and 32, and neither of those are prime, so I can forget about that. It has 4 and 8, and 4 is a perfect square, so maybe that would work. It also has 2 and 16, and 16 is a perfect square. And this is the pairing that we're going to use because 16 is a larger perfect square than 4. So I want to use the 2 and 16 route set of factors instead of the 4 and 8 set of factors. Because again, 16 is the larger of the two sets of perfect squares, or of the perfect squares that we have in our factors. So I'm going to rewrite underneath here 2 times 16. And then our rule is if you have an odd exponent, you're going to subtract 1. So I'm going to do m squared times m. Because m squared times m is m to the third. But I have to have even exponents in order to take the square root of them, in order to simplify the radical. So here's my perfect square right here. And here's my perfect square right here. And since they're perfect, right, I have a perfect square here and I have an even exponent, I can take the square root of them. I can simplify those radicals. So the square root of 16 is 4. And the square root of m squared is m. So I did both of those. And these two that are left behind are composite numbers. They're not perfect squares. And so they stay under the radical. So the simplified answer for the square root, or radical 32 m to the third, is 4m radical 2m. So let's do another one. Let's do, let me switch my colors back. Let's do 96 p squared. So again, I'm going to look on my factor squares at the factors of 96. There are a lot of them, so let's write them all down. There's 1 in 96, 2 in 48, 3 in 32, 4 in 24, the big list, 6 in 16, and 8 and 12. So I'm just going to start going through and I'm going to look for perfect squares. This doesn't have a perfect square, so I can cancel it out because my perfect squares are over here. 2 and 48, no perfect squares. 3 and 32, no perfect squares. 2 and 24, nope. 6 and 16, 16 is a perfect, so I'm going to put a square around it. And then 8 and 12. So my factors that I am going to use for 96 are 6 and 16. So I'm going to do 6 times 16 times p squared. And I'm going to leave it p squared because it's an even exponent. And that's what I want. If I had an odd exponent, I'd have to subtract 1 out. But it's an even, and so I'm good to go. So I can do the square root of 16 because it's in my list of perfect squares. And I can do the square root of p squared because it's even. Square root of 16 is 4. Square root of p squared is p. And I've done both of those. And 6 is left behind. So I'm going to leave that underneath the radical. It's going to stay the radicand. So my answer is 4p radical 6. Let's do a couple more. And again, your factor squares are going to be super helpful during this whole thing. So let's do the square root of 75 n to the 5th. That's 7. Let's make sure you know it's a 7. 75. All right, so 75. If I look at my factor squares. 75, 1 and 75. What else? 1 and 75. 3 and 25. And 5 and 15. No perfects in that set. I have a perfect right here. And nothing in there. So my factors that I'm going to use are 3 and 25. So 3 times 25 is 75. And n to the 5th, that's an odd exponent. So I'm going to take 1 away. So I'm going to have n to the 4th times n. And 25 is a perfect square. And n to the 4th is a perfect square because it's even. Even exponents are the perfect squares. So the square root of 25 is 5. And the square root of n to the 4th is n squared. Because in order to get n to the 4th, you do n squared times n squared. And what's left behind is 3n underneath the radical. My handwriting is terrible up here. All right, another one. Let's do, I want to find one that doesn't have 16 as it's perfect. Let's do 50 m to the 4th. So 50 is 1 and 50, 2 and 25, and 5 and 10. I'm not going to use 1 and 50. 25 is a perfect square. Nothing down there. So I'm going to do 2 and 25. 2 times 25 times m to the 4th. Sorry, my niece is texting me for homework help on her math. We have 25 as perfect. And we have m to the 4th because it's even. Square root of 25 is 5. Square root of m to the 4th is m squared. Because again, to get m to the 4th, you do m squared times m squared. So those are two of the same things that get multiplied together to make it, so I can do the square root. And radical 2 is left behind. Let's do a big one. Let's get a big number. All right. The number that's not on our factor list. 128. 128 r to the, let's do to the 9th just for fun. All right. So when numbers aren't on your list of factors, the easiest way to do this is to do prime factorization. So, grab your calculator. And I'm going to factor 128. So 128 is even, so I can divide by 2. So that's 2 and 64. Look, it's perfect. Or it's a perfect square. See? You can do it. You just have to sometimes factor a little bit, take a number out. K to the 9th is odd, so that's not K, that was an R, wasn't it? R to the 9th is odd, so I'm going to do R to the 8th times R to the 1st, because together they make the 9th. And since it's even, I can do the square root of it. So it's R to the 4th times R to the 4th. So the square root of 64 is 8. The square root of R to the 8th is R to the 4th. And left behind underneath the radical is 2R. Let's say you had a number like 620. So the square root of 620 x to the 5th. Why not? And you wanted to factor this. I could do 10 times 62. And 10 is 2 times 5. And both of those are prime. So I'm factoring down to the prime values. And then I'd go to 62. And 62 is 2 times 31. And since I have a pair of 2's, I can link them together. So 2 times 2 is 4, which is our perfect value we're looking for. 5 times 31, those aren't perfect, right? There's no, and they're prime. There's no way to get them factored down any further. And so we're going to combine them to 155. And again, 155 is that value where we can't take any more perfect numbers out of it because it's the result of this prime factorization. And then I'd have x to the 4th times 1, because this is x to the 5th, and I want to make it even, so I subtract 1 out. So the square root of 4 is 2. Square root of x to the 4th is x squared. And 155x stays underneath the radical. Those ones are a little tricky. There shouldn't be very many of them, if any at all, on your homework, just because big numbers sometimes throw us for a loop just because of that prime factorization part. The other part is you may have a number like 77x. Let's just do x, right? Well, 77, the only way you can get 77 is 1 times 77 or 7 times 11. And neither of those have any perfect values inside of them, right? So this is an example of a number. 77 doesn't have any perfect factors that you can factor out. So 77 is just going to say 77. There's no perfect breakdown. And x, it's an odd exponent of 1. So it just stays 1 because I can't subtract anything from it. And so my answer is just radical 77x because there are no perfect factors that we can factor out. There's no perfect number factors for 77, and there's no way to make this an even exponent by subtracting 1 because it is a value of 1. So hopefully that explains a little bit more about factoring radicals. We just have the one lesson over it, but I wanted to just kind of show it to you because it is something that will really help with geometry next year.